Hey guys, the objective of this video is to introduce the expected value and variance of x, which is our continuous random variable. So let's start with the expected value. So if x, our random variable, is continuous and he has a probability density function of fx, that means the mean or expected value of x is the integration of negative infinite to infinite of x times fx. So ex is our expected value. That's what we denote the mean or expected value of x to be, or we can also denote it as mu. So the expected value of, let's say, a function gx, that basically is an integration of negative infinite to infinite of gx times fx. So remember, fx is our probability density function. So let's go for an example. So now, an example of a continuous random variable is called a uniform distribution. So the one that we looked at in the last example was called the exponential distribution. This one here is called the uniform distribution, denoted as UAB. So its probability density function is fx equal to 1 on b minus a for a range of x between a and b, and it's 0, fx is equal to 0 elsewhere. Okay, so on x's that are not in between this range of a and b. So if we actually sketch that out, so that will become this. So we have a line of 1 over b minus a, okay, between the range of a and b, and the rest of it is just 0. So you can clearly see here that the total area under the box is equal to 1. Okay, so the height, here is 1 minus b. So 1 over b minus a, okay, and this length here is b minus a. So the total area is b minus a times 1 over b minus a, and that's equal to 1. So the total area under the fx is equal to 1, so therefore our fx is a probability density function. So the probability of x being less than or equal to I is equal to this, okay, where the integration is between negative infinite to I, 1 over b minus a times dx, because our fx is equal to 1 on b minus a. So when we want to find our expected value, we need to follow the formula. So remember, this is our continuous random variable. So we need to take the integration of negative infinite to infinite of x times our fx, our probability density function, times dx. So our fx is 1 on b minus a, going from the range of a to b. Okay, so the reason why now I've changed the bounds is because on x's that are not between a to b, okay, the fx becomes 0. So now we do integration of this, okay. So this comes out to be like this, where we have half x squared times 1 over b minus a. Okay, and this is the result of the integration. So when you stop in the bouncing the a and b in, that will give you this, and eventually the expected value will become half a plus b. So we can therefore conclude that for our uniform distribution, the expected value is equal to half a plus b. So this is how we can use the formula for expected value of a continuous random variable. Okay, so let's go to variance. So if we want to calculate the variance of a continuous random variable, we denote that as sigma squared. So that's equal to this, okay? So that's basically equal to the integration of negative infinite to infinite, x squared times fx times dx, minus the integration of negative infinite to infinite, x times fx times dx, the entire thing squared. So this is how we can find the variance of x. And remember, fx is our probability density function. So you just basically sub it in, and you basically have to evaluate the integration to find our variance. Alright guys, I'll see you in the next video.